figures. Okay, so at the top, it just says, how can we prove these two triangles are similar? So it's not telling us they are, it says, how can we prove that? Right away, I would be like, hey, we got some vertical angles, so I would mark that up. All right, now, I don't know for sure that they're similar because it didn't tell me that, so I'd have to show. And so let me see if we got some sets of corresponding sides we could see if they were in proportion. If I look at the side that says 12, what side would that go with in the other triangle? Would it go with the 18 or the 24? The 18. 12 is the smaller number, 18 is the smaller number. All right, just going to switch that up. And then so the 16 has to go with the 24. We don't know if they're similar or not yet, but the X and the 10, those would correspond to each other if they are. So we're just going to check this really quickly. If I have that angle in between with my vertical angle, we're just trying to ask, is 12 over 18 equal to 16 over 24? That'll show if our sides are in proportion. So if I reduce both of those fractions, do they reduce to the same thing? You could actually, if you guys wanted to do this, you could actually check the proportion. Do like 12 times 24, see if that's equal to 18 times 16. That's another way you could check, or just see if that's actually true. That'll tell you that they reduce to the same thing. They do actually reduce to the same thing here. Both of these are divisible by 6, so this reduces to 2/3. 16 and 24 are both divisible by 8, also reduces to 2/3, and that actually answers the question right underneath that is, what's the similarity ratio? It'd be 2 to 3. And what I'm using there, I showed two sets of sides were in proportion and the angle between by vertical angles. So this is side angle side similarity is what we're using there. If I call the first triangle ABC, this is a little bit tricky because it's twisted. So I go down my side, I colored kind of orange to the vertical angle and then the green. So I have to repeat that. So the other one I'd have to label EBD to make sure I matched up the corresponding parts. Okay, now this last part, and a lot of these questions I think are tricky because you really do have a lot of different options that would be correct to solve the problem. So you can use the sides in the diagram like to set up a proportion, or you can also use the similarity ratio. So let me actually do that for this question. So I know the relationship between these two triangles is 2 to 3 or 2 over 3. And if I use the similarity ratio, I'm just going to ask you a quick question to help me set up my proportion. Is the 10, I'm going to try to find X that corresponds to the side that's 10. Is the 10 in the smaller triangle or the bigger triangle? Smaller. So all I'm going to do, I'm going to match the smaller number up with the smaller number on the top. The 10's in the smaller triangle, so you put that with the smaller number. X is in the bigger triangle, so you match that up with the bigger number. And that's all you do. You could just use the similarity ratio. Now, if you wanted to, you could use the sides. You could do like 12 over 18 is 10 over X. You could also do 16 over 24 equals 10 over X. Any of those would give you the answer. You can also use the similarity ratio, and I promise if you solve any of those proportions, you'll get the same answer. It's just going to be a little bit different work. If I use the similarity ratio here, we just get 2x equals 30. So divide by 2, x is going to be 15. And if you solved either of these other proportions I wrote down as examples, they would all give you that x is 15. Lots of options in a lot of these questions. Is anybody having a question? Okay, on this next example, I am not going to do we're just going to skip this guy, okay? Because I need some space. And the question next to it is a little bit weird. We have done a couple problems that looked a little similar to this, but maybe not having an X where I have an X in this diagram. Okay, so you don't have to, but I would maybe recommend, I'm just going to separate the two triangles in this picture real quick because it usually makes it a little bit easier to match up corresponding parts here. Okay, first of all, it doesn't tell me they're similar, but I could show you they're similar really quickly. Do you guys agree both of those triangles share that angle that I just marked there? So like right here. And I don't have more than one set of sides, that would be something I could compare. So I can't show any sides are in proportion, but what I can use here, if I have these little extra arrows, that's parallel lines. Now, two different arguments here. This corner here and this corner here, those would be just a set of corresponding angles. So if I've got those parallel lines there, if I use this side of the triangle as a transversal, those two angles, I just marked corresponding angles, and automatically I could have angle-angle similarity because I already have the set from the top. You can also make an argument here. This corner, I'm just going to go 1, 2, 3, and this corner, I'm going to go 1, 2, 3. That would be another set of corresponding angles from the parallel lines that have to be congruent. I'm just using this side of the triangle as a transversal. So if I needed to defend, do I know these are similar? For sure, by angle-angle similarity. Okay, now here's the tricky part. I'm just going to label the little yellow triangle, right? This side is 15, this side is 12. Now the one I outlined with my orange highlighter, all the way across here is 20. The side I think is really tricky to do is this side here. So in the original picture, how would you write this whole side? Like how would I, and it's weird because it has an X with it, but how can I write an expression for that side of the triangle? Anybody know? So I'm going to go down like this whole side here. How would you write that based on what you have in the picture? What do you think? I thought you were raising your hand.
No, I'm sorry.
Okay, let me make up something. Let me pretend I have, where I have an X there, pretend I have a 3.
Wait, are we talking about?
I'm talking about this side right here. How would I write this? So I've got this little piece is X. That's it. Okay, that's what I was trying to get you to say. So I don't know what this is. I would put the X first. So I'm just going to write X plus 12. Okay, now once you're there, you've got enough information to set up a proportion of corresponding sides. Sorry. Okay, so the 20 is going to go with the 15, right? Those are in corresponding locations there. So the 15 and the 20 go together, and then you're going to have the 12 and the X plus 12. So however you want to set it up, I'm just going to put the smaller triangle on top. So I'm going to say, all right, 15 over 20 has to be in proportion to or equal to 12 over X plus 12. Only thing you got to remember here is if we have an X plus 12, I just want to put that in parentheses because when I do my cross products, I want to make sure I multiply 15 by both of those terms. Okay, so if I do that, 15 times X is going to give you 15X. 15 times 12 is going to give you 180. And then my other cross product is just going to be 20 times 12. That is 240. From there, it's not too bad. You're just going to subtract 180. We'll get 15X equals 60. And then what would X end up being? Anybody know? I think it's a nice number. 60 divided by 15? Yes, should be 4. All right. Anybody have any question about the most important part I want to make sure you understand? Do we understand where the X plus 12 came from? Does anybody not get that? Okay. Now, I'll do another one. This is maybe a little bit more straightforward, but I got to read the question carefully. It says triangle CAT and triangle PIT are similar to each other. So you don't really need to mark this, but I would have vertical angles right here if I needed that for some reason. Really, I just want to set up a proportion here. It says find the length, or what is the length of TP. So T to P is this segment right here. The 6x minus 1. Okay, so we're going to have to find x here, but to find the length of that segment, I'm going to actually have to plug my answer back in to figure it out. Yeah, these guys correspond to each other.
Well, yeah. Well, I know it's because the thing is smaller, so I was wondering if that would just happen to be each other.
We don't want to set them equal. We want to just, any of these questions, we just want to set up a proportion. So I'm just going to match up the corresponding sides, right? All right, so I'll put the smaller triangle on the top. So 20 and 28 would go together. So those two sides correspond to each other. You can, if you want to, reduce this, but you don't have to. You can leave it right like that. It's up to you. Now, to set up the other side of that, we're just going to use the other set of corresponding sides. So the 3x plus 7, that was in the same, excuse me, that was in the same triangle with the 20, so I put that in the same part of the fraction. The 6x minus 1 is in the same triangle as the 28, so I'm just matching that up with the same part of the fraction. All right, so if you want to, you can reduce this. If not, I'm just going to go ahead and cross multiply here. Now, if I do 20 times 6, I'm going to get 20 times 6x, 120x. 20 times 1 is negative 20. My other cross product, ooh, I don't know this off the top of my head. So 28 times 3x, so 28 times 3x, 84x. And then 28 times 7 is 196. Okay, completely up to you. If it's me, I like to try to keep my variable positive. So I would subtract 84x from both sides. So we're just doing 120 minus 84. Do what? I didn't write out all my work. I just
did the cross. I was just going to put like 5 is like, I don't know.
I don't want to, no, not right now. Let me just finish this up. Okay, it won't take that long. I'm going to add 20. I'll look at it in a second. All right, so I'm going to get 36x. If you take 196 and add 20, you should get 216. And this is actually a nice number. Divide 216 by 36. X is 6. Okay, now just be real careful with this because that's not the answer to the question. The question says find the length of TP. Excuse me. So to do that, we're going to plug that back in, sorry, to that expression. So TP is that 6x minus 1, and we now know x is 6. So my actual answer to the question would be that TP is 35. You don't need to write out all that work. I was just trying to show you where it came from. But I would be looking for 35 as my answer. Okay, is anybody having a question? Okay. Yeah, if we should get the same numbers if you reduced it. Should get the same exact answer. Okay, now on the back, this thing called indirect measurement, which I just had the definition typed out here for you, basically uses similar figures to find a missing side length in another similar figure. So it says indirect measurement is a method of using proportions to find unknown length or distance in similar figures. Now, the most common ways is if we have a shadow of some kind, or also if we use a mirror. So I'm going to explain these in both of these questions down here. So just give me 1 second. We're going to start with the shadow. So this is a typical use of indirect measurement. All right, so the concept behind this is we'll have two objects near each other outside at the same time. So it says in sunlight, I have a vertical yardstick. So vertical just means straight up and down. And the yardstick casts a 2-foot shadow. Your shadow would go along the ground, right? So 2 feet. And because of the angle to the sun, the idea behind this is the sun casts the shadow, and I'm just going to see if my pen will work here, but this would make it into a little right triangle. We're going to assume if you have a yardstick or a person or a lamppost or whatever, if they're standing on the ground, that's going to create a right angle with the ground, and that's going to create similar triangles is what's going to happen. Okay, now let me ask you a question. Can I label the length of the yardstick? Like, so in my triangle, it said the shadow was 2 feet. What would you write down for the length of the yardstick? What were you going to say? Oh, I thought you were, it's 3 feet. Now, you can use 1 yard, all right, but I'm going to ask you for the answer in feet for this question. So if you don't know this, maybe jot this down. 1 yard is equal to 3 feet. So I'm going to go ahead and put that my yardstick is 3 feet tall. Okay, once I got that, then it says, at the same time we have a person. You can be very impressed by my drawing skills. Here's my person. Casts a 4-foot shadow. So again, the shadow goes along the ground. I'm sure I'm not drawing this to scale. And the sun coming from behind the person is going to cause the shadow to go along the ground. And we're going to assume the person makes a right angle with the ground. Now, how tall is the person in feet? I would literally just put my variable as the height of the person. So these are similar triangles here. And all I have to do is just quick set up my proportion. So my 3 feet for the yardstick would match up with my height for the person. And then my shadow for the yardstick would match up as a corresponding side with my shadow for my person. So all I have to do, I'd do something like 3 over x has to be equal to 2 over 4. If you set it up differently than me, as long as our cross products are the same, we're fine. There's just a lot of different ways you can set these up. If I do my cross products here, I should end up with 12 equals 2 times x. And then I'm just going to divide by 2 real quick. So x would be 6. So that means this person is 6 feet tall. Once you set up the picture, it's usually not really bad to solve it. It's trying to set up the picture from the description. Okay, now this one I have here is using a mirror. This is kind of like a weird thing, but you can actually do this in real life. So it says, before rock climbing, this is not the greatest picture I have ever stolen from the internet, so please forgive me. There is supposed to be like a mountain here that we're gonna rock climb, and the person that is gonna climb this is down here in the corner. I don't know if you can see it. So I might draw this to the side so we can see this a little bit better. But what it says Darius wants to know how high he's gonna climb if he climbs up on this mountain. It says he places a mirror 34 feet from the base of the cliff. So from the very bottom of the mountain, I don't know if you guys can see this very well in the picture, the mirror would be like right here. If we were to actually go outside and do this to try to measure something, what you would do is you'd put the mirror on the ground, back away from the object, look at the mirror to see the reflection of the top of it. So that's what this is going to say. He can see the top of the cliff in the mirror if he backs away from it. He's 6 feet away from the mirror. The mirror is 34 feet from the base of this mountain. He's 5.5 feet tall. He wants to figure out how tall the mountain is. If that picture is hard to see, which I think it kind of is, let me just redraw this real quick to the side so you guys can kind of see what's going on. So the mirror is in the middle. The mirror is 34 feet from the base of the cliff, and he is 6 feet from the mirror. Darius is 5.5 feet tall, and then we want to figure out how tall this mountain is that we're going to climb up on. So the distance from the mirror is going to correspond to each other, so the 6 here and the 34 here, and Darius's height, 5.5, and the height of the mountain are going to correspond to each other. So one way to set up my proportion here, I could do, let's see, 5.5 over x equals 6 over 34. And as long as your cross products were the same as mine, then we can set these up differently and still get the same answer. So I'm going to take 5.5 times 34 there, which I think is a nice answer. Yeah. Okay, 5.5 times 34 is 187. I just wrote that wrong, 187. And then 6 times x would be your other cross product, which would be 6x. Okay, now this is not a nice number, so I'm going to do 187 divided by 6. I'm just going to do, let me just do one decimal place here. I'm going to say this is about 31.2 feet. Is anybody having a question?
I was trying to figure out how you convert like just to like a fraction, 31.16, all that and stuff.
If as a fraction, it's 187 over 6. You can't reduce it. It's just not a nice number. Okay. Now, very similar problem, but really what I want to target in this example is how would you write these heights? Okay, so let me just read this to you real quick. It says Jenny is 5 feet 3 inches tall. So this is this girl here. And it says to find the height of a lamppost, she measured her shadow and the lamppost shadow. So her height would correspond to the height of the lamppost, which we don't know here. And her shadow is going to correspond to the lamp post's shadow, which is going to be along the bottom there, along the ground. All right, now, pretty straightforward to set this up. It's just that her height and her shadow are kind of tricky to set up, I think. So if she is 5 feet 3 inches, her shadow is 7 feet 9 inches. The lamppost, I just put a variable with that. We don't know that, so I called that X. The lamppost shadow is 5.5 feet. I want to convert her height and her shadow just into feet. All right? How would I write, so she's 5 feet, right? How would you write 3 inches in feet? It would be a decimal. Does anybody know how you would go about doing that? Like, how would I write 3 inches into feet? Okay, now let me ask you this question. All right, most people see this and they set up their proportion and they do like x over 5.3 equals 15.5 over 7.9. All right, so don't write this on your paper. 5.3, I do not want to see that. If I have 3 inches, how many inches are in a foot? 12. Okay, so see if this makes sense. If I have 5 feet and then I have 3/12, right? 3 out of 12 inches, 3/12, if you want to grab your calculator, I would just do this as a decimal. So it's 1/4, but if I divide 3 by 12, it's going to give me 0.25. So 5 feet 3 inches is really 5.25 feet. I'm just taking the inches and dividing them by 12 to write that as a decimal, just to make it easier to do the proportion. So just don't put 0.3. That is always what people will do on this type of question, but it's not, because there's 12 inches in a foot, you have to divide the inches by 12.
Could you convert it to all inches?
You could convert it to all inches. Okay. Yes, I was going to say that too. All right, let me do it to feet first, just real quick, because I think that's a little trickier. All right, so if you do 7 feet 9 inches, 9 over 12, I would just do the same thing. There's 9 inches here, and we have 9 out of 12, so that's 0.75. All right, so this would be, for her shadow, 7.75. Oh my goodness. 7.75 there. Fail. Now, from right there, you could go ahead and set up your proportion. The other thing you can do is you could convert everything to inches. If you wanted to do it like that, again, you don't know the lamp post. What you want to do if you want to convert feet to inches is just multiply by 12. So if I do 15.5 times 12, this would be 186 in inches. And then for the girl, 5 feet times 12, you'd have 60 plus 3 inches, so it'd be 63 inches. And then she has 7 feet times 12 for her shadow, plus 9, so then you'd have 93. That would be in inches, so you could do it either way, but you want to try and make it so you have the same units. It's totally up to you. Now, if you set up your proportion, and this question doesn't specify, it doesn't say I have to put it in feet or inches, so you could do either one here. If I did x over, let's see, the 5.25, that would be equal to 15.5 over 7.75. And just cross multiply here, you should get 10.5 feet. If you do it in inches, the setup would be something like x over 63 equals 186 over 93. Cross multiply here, I can't remember what that is off the top of my head. So 63 times 186, if you want to do it in inches, this is a huge number. I'm going to divide that by 93. This would be 126 inches. Now, if the question specified and said like, hey, I want this in inches or I want this in feet, you can just do a quick conversion. If you have inches, you just divide by 12 to get feet. If you had feet, you can just multiply by 12 to get inches. So just going to kind of depend on the question, but there's different ways you can tackle this. Please don't write like, see 5 feet 3 inches and write 5.3, because that's not correct. That's just what I wanted to emphasize on this. Is anybody having a question? Okay, let me just do one more. This one just deals with a rectangle instead of a triangle. So it says dimensions of a widescreen TV have a rectangular ratio. So I'm just going to sketch a little rectangle here. And the ratio is 16 to 9. So I'm just going to label the longer side 16 and the shorter side 9. All right, now it says if the longer side of an actual physical television is 2 feet, how many inches tall is it? So here will be my actual television. And it says the longer side, so I'm going to match that up with the larger number, is 2 feet. We want to find how tall it is, but it specifically in the question says how many inches tall is it? What would you maybe do before you tried to set up a proportion here if you want your answer in inches? Yeah.
The dimensions are 16 and 9.
Yep.
16 and 9 is what?
That's like if you get on a TV, like you'll see that as an option for the ratio. Usually that's when they have the shadow box, like if you're watching a movie, like it's black on the top and the bottom of the screen. That's just a dimension, it's like a setting on the TV. The other one's usually 4 to 3, and that one doesn't have the little boxes in the No, it's not anything, it's just the ratio. This would be like an X and an X. Like it's not standing for a specific length. But what I would do here, if this is in feet and I want my answer in inches, I would just convert this real quick. How many inches are in 2 feet? 24. All right, now, if I do this, my answer will automatically be in inches because I just set it up that way. The 16 and 9, that is just a ratio. It's not an actual length. You guys probably, if you would go home and look at your TV settings, this is an option you can have. It creates a little box on top and the bottom of the screen to show movies is usually, they call it a shadow box. But anyway, so I would just do something like, do 9 over x equals 16 over 24. And then we can just cross multiply, divide there to get the height of the TV. It's going to be really small. 9 times 24 and then divide that by 16. So the height of the TV is actually 13.5 inches. So this would be a little mini TV. All right, is anybody having a question?